That's not too bad. Let's go ahead and get started. So piecewise functions, something we haven't done in a while. This is a problem actually I made up because it was something that's a student typed in and it wasn't fully completed. So I just kind of made one up and tried to see what we could do from there. All right. So the basic understanding to what you want to do for a piecewise function is really understand what we're trying to do here is we're really just trying to graph these three functions on the same graph. Now, obviously, we can't graph all of these three functions on the same graph because then they would overlap each other and it wouldn't be a function, right? So that's why we restrict a graph. And that's exactly what these little versions over here is. These are the restrictions. So what these represent is how the graph is going to be restricted. So for instance, the graph x squared looks like this, right? Or roughly looks like this. Well, now we're going to say only restrict this graph from x is less than -1. So let's say -1's right here, positive 1's are here. So here is my value from -1 right there. Right? So if I kind of take that open value, right, less than, not less than or equal to, it's going to be an open circle and then going to the left. So that's the portion of the graph that we want it to, that's going to be a part of this piecewise function. That means everything else I can actually delete, right? So we're only going to be working on the version of the x squared where it's less than -1. So now let's do the next graph, y equals 3x. So again, that's going to have a y-intercept of 0. Let's go up 1, 2, 3, over 1, and down 2, 3, to left 1. So that graph looks something like this, right? Now, in this case, we're trying to graph this from -1 to +1. But now this is included. So it's going to be less than, or x has to be greater than or equal to 1, but less than or equal to +1. And it's going to be everything in between. So we're only going to actually include, the only portions of this graph that's included is from -1 to 1. So therefore, we can eliminate or delete the rest of it. And the last one is y equals 4 to the x. Where x has to be greater than or equal to 1. So this one's a little bit more difficult to kind of see what this graph would look like. The 4 to the x, that's going to be like a vertical stretch. And so I'm not really sure as far as the points. I think the one thing that we want to make sure that we kind of understand about this graph is that there's still going to be a horizontal asymptote at 0 and a vertical asymptote at x equals 0. Now, the only thing is if you actually plug in 1, even though 1 is not defined, if you plug in 1, you would get the number 4. So 1, 2, 3, 4. So I guess that's going to be an open circle. Now, again, I know this graph, the shape of the graph looks like this, right? So as I keep on going to the left, as I keep on going up, it's going to go farther to the left. So this graph, that was going to look something like that, where it's not going to intersect because you can see like from there to there it's crows. And again, I'm trying to do my best with what I have. But you can see how that graph is going to, typically going to keep the same shape, but everything over or larger than 1 is going to be going over there to the right. So because 1 would be at 3, 1 would be at 4, and then it'd be go to the right. So there you go. At least hopefully that's the best. The best advice I can do for piecewise functions is graph each function separately.